Jacobian, if we're going from x, y, z over to what? Rho theta phi will be equal to the determinant of partial x with respect to rho, partial x with respect to theta, partial x with respect to phi. Then partial y with respect to rho, partial y with respect to theta, partial y with respect to phi. Partial z with respect to rho, partial z with respect to theta, partial z with respect to phi. I need the determinant of that. Nasty. This will be equal to, okay, see if you can follow me on this. I'm going to write it down here low. Partial x with respect to rho, which is this one, times the determinant of this. So the determinant of that is partial y with respect to theta, partial z with respect to phi, minus partial z with respect to theta, partial y with respect to phi, minus, because remember that's what you do, you switch. Now I'm doing this one, so partial x with respect to theta times the determinant. I cover up this column. I'm doing determinant of these two and these two, so that and that. So partial y with respect to rho, partial z with respect to phi, minus partial z with respect to rho times partial y with respect to phi. Okay, plus this one right here, partial x with respect to phi times the determinant of this little 2 by 2. So partial y with respect to rho, partial z with respect to theta, minus partial z with respect to rho, partial y with respect to theta. Okay, if I could just compute that, I'll have the Jacobian. So that's going to be a mess. Now, I'm going to need some things here in order to do this. I'm going to need the partial of this with respect to rho, partial of this with respect to theta, partial of this with respect to phi. So let me get all of those and just put them next to it. The partial of x with respect to rho equals, so this is our variable, everything else is a constant, cosine theta sine phi. Okay, what is the partial of x with respect to theta? Well, this time, treat rho and sine phi like constants. So derivative of cosine theta is negative sine theta. So I'm going to get negative rho sine theta sine phi. Okay, then I need the partial of x with respect to phi. So I'm just taking derivative of sine phi, which is cosine phi, and that's a constant. So rho cosine theta cosine phi. I also need all the partials for y. So the partial of y with respect to rho is sine theta sine phi. Partial of y with respect to theta, I just take derivative of sine theta as cosine theta, so rho cosine theta sine phi. Partial of y with respect to phi is rho sine theta cosine phi. So that was a derivative of sine phi is cosine phi. And I need all the partials with respect to, or of z. So the partial of z with respect to rho equals cosine phi. The partial of z with respect to theta is 0, because there is no theta here. And then the partial of z with respect to phi is negative rho sine phi. Okay,
Remember, our goal here is for me to show you that the absolute value of the Jacobian is going to turn out to be that. All right, what a disaster. All right, let's see if I can get this. Which of these are 0? Partial z with respect to theta. Here's partial z with respect to theta, right? So this is all 0. This whole thing gets zeroed out. So when you do this first distribution here, it's going to 0 out. Then over there, it's not. So what I'm going to do is I'm just going to tweak this formula a little bit. I'm just going to go this. It's going to be this times this, right? That might make it a little bit easier. That's the only place that partial z with respect to theta appears. All right. Partial of x with respect to rho. This right here. Cosine theta sine phi times, let me try and do this distributing all at one time. This times this. Partial y with respect to theta is right here. So times rho cosine theta sine phi. But then this was also multiplied partial z with respect to phi, which is times negative rho sine phi. Just remember, this is all multiplied together. So it's that times that times that. Okay, that's just this distributed through. Now this to here is going to be minus. You're going to have this again. So cosine theta sine phi. But this time times negative. Or wait, I already did minus. Hold on a second. Yeah, I already did the negative. So it's that times this and this. Cosine z with respect, cosine z with respect to theta. We had it twice. Oh, that's 0. Bam, that's awesome. Okay, I didn't recognize that before. That's gone also. So I don't have this second multiplication, so I don't have that piece. Good. All right, let's do this one now. Here to here. So we do get minus. Partial of x with respect to theta is this. Negative rho sine theta sine phi. But then you're also multiplying that times partial y with respect to rho, which is sine theta sine phi. But then you're also multiplying times this, partial z with respect to phi, negative rho sine phi. Okay, so I've taken care of this. Now I've got to go this to this. Negative negative is plus. Partial x with respect to theta, negative rho sine theta sine phi, running out of room. And then partial z with respect to rho, cosine phi. And then partial y with respect to phi is rho sine theta cosine phi. And I still have to do this one over here, but I'm out of room. So I'm gonna squeeze it in here. It's going to be this times this. So it'll be negative partial x with respect to phi. Here, rho cosine theta cosine phi times partial z with respect to rho cosine phi. And then partial y with respect to theta, which is rho cosine theta sine phi. All right, that is it. Now let me clean this ugly thing up. Okay, let's look at the rows here. We have rho here, negative rho here. That's negative rho squared. Okay, cosine theta, so I have cosine squared theta. I don't have any sine thetas, but I have sine phi, sine phi, sine phi, so sine cubed phi. You know, I think I'm going to write this above. Easier for me to write. So I have negative rho squared cosine squared theta sine cubed phi. Okay, that's what I get when I put all this together, so I'm done with that. Okay, over here, let's see, negative negative is plus, but then negative again, so I have negative. I have rho and rho again, so that's rho squared. Okay, I have sine theta, so sine squared theta. I have sine phi, so sine cubed phi again. And that takes care of this. Okay, let's do this one right here. I've got negative rho and rho, so negative rho squared again. I've got sine theta, so sine squared theta. I have sine phi, cosine phi. So sine phi cosine squared phi. And then the last one, negative rho and rho, negative rho squared, cosine theta, which is cosine squared theta. I have cosine phi, sine phi. So that's sine phi cosine squared phi. That takes care of the last ones. So I should have 4 pieces up there, which I do. And now I've got some really cool things happening here. Greatest common factor, just look at these 2 terms right here. Right here. They both have a negative rho squared. They both have a sine cubed phi. So I factor that out of both. And when I do that, I'm left with, if I take negative rho squared and sine cubed phi, I'm left with cosine squared theta. If I do the same thing over here, took out the negative rho squared and sine cubed phi, I get plus sine squared theta. And we all know this is 1. So that's going to be real nice over there. Over here, if I focus my attention on these, they both have a negative rho squared. I can pull that out. They both have a sine phi cosine squared phi. So I'm going to pull out a sine phi cosine squared phi. If I do that, I'm left with a sine squared theta plus a cosine squared theta again, which is a 1. It's beautiful. So I'm left with negative rho squared sine cubed phi minus rho squared sine phi cosine squared phi. And notice that these both have a negative rho squared sine phi as a common factor. I pull that out, I'm left with sine squared phi plus cosine squared phi, which again is 1. So you're left with negative rho squared sine phi. And then this is the Jacobian. Then if we take the absolute value of this, we get rho squared sine phi, which is your conversion factor whenever you're doing spherical coordinates. So I hope that that was kind of cool to see. It's a nice derivation, and it shows how to use that Jacobian determinant on 3 by 3. So switching from 3 variables to 3 new variables. Okay, that's it for this section. Do your homework and you should be good.